Now we're going to get into the metric system. So we've only been working with our system, the U.S. customary system of measurement. We're going to start talking about the metric system, how the metric system works. The really nice thing about the metric system is that it's all based off of powers of 10. So the converting sometimes tends to be a little bit easier in the metric system because you're simply like moving decimal places instead of actually taking numbers times new numbers. And then we'll get into a little bit later in this chapter about actually going between the two systems. But so, like I said, we're going to focus just mainly on the metric system, kind of get you guys some basics about the metric system. So most other countries use the metric system. We're kind of one of the oddball countries that doesn't use the metric system. And like I said, it's all based off of the power of 10. So every unit, so like if you're talking about centimeters, like centimeters to meters to kilometers, all of those are related by just a power of 10. So you're just increasing something by multiplying it by a power of 10 of some sort. So like times 10 or times 100 or times 1,000. The standard unit is the unit that assumes the position of the ones place in our place value chart. And that's the word that all of the other prefixes attach to. So like meter, gram, and liter would be like the main standard units, because then we have like centimeter, millimeter, kilometer, and those kind of things. Those get added to our standard units. So a meter would be used for length or for distance. So if you're measuring how long something is, or like the distance between places. Gram is used for mass or for weight. So it's talking about how heavy something is. And then liter is used for capacity or volume. So how much liquid can be filled into something. So these are the three main ones. And like I said, those are your standard units. And then we have prefixes, which we'll talk about in a minute, that get attached to these three words. And it changes their meaning a little bit. So it either makes them smaller or it makes it bigger than the standard unit. So the first thing we're going to do is just kind of go over like what are some of those prefixes and like what do they mean in relation to the standard unit. So some of the most common prefixes for units that would be smaller than the standard. So like smaller than the meter, smaller than the gram, smaller than the liter. One prefix would be deci, D-E-C-I. That means 1/10 of. So like a decimeter would be 1/10 of a meter. The next one would be centi. Centi would be 1/100 of. So a centimeter would be 1/100 of 1 meter. And then the last one is milli, so like millimeter or milligram, and that would be 1/1000 of. Then we have common prefixes for the larger units. So those would be deca, D-E-K-A, which means 10 times. So 10 times like a meter or 10 times a gram would be like a decagram. Next one is hecto, so like a hectogram. That's 100 times bigger. And then the last one is kilo, which would be 1,000 times. So we use these prefixes a lot to talk about the different ways that we can measure. So if you're doing really small items, you're probably using like a centimeter or a millimeter, or like a milligram or anything like that. And then if you're using a bigger unit of measurement, that's when you'll see things like decagram, hectoliter, or like kiloliter, kilogram, kilometer, or those kind of things. So what we're going to do first is take a look at these. And they want us to give the value of the metric unit using the standard unit, your gram, liter, or your meter. So gram Liter, meter would just be like 1. And so we're trying to write out what would it look like then if it was converted to like a kilogram or a milligram or something like that. So the first one wants us to go to kilograms, which is abbreviated kg. So remember that grams would just be 1. So kilogram meant 1,000 times. So you would be taking 1,000 times 1. So that would be the same thing as 1,000 kilograms. Number 2 says deciliter. What did I say that deci meant? Up above? 1/10 of. So we're taking 1/10 times 1. Which if you think, that's like 1 divided by 10. So you're moving the decimal place. So it would be 0.1 liter. Hectometer, HM. Hecto, remember, meant 100 times. So we're taking 100 times 1. So that would be 100 meters. Okay, so why don't you guys take a minute and try to do 4, 5, and 6. So what does the prefix deca mean? 10 times. So you should have taken 10 times 1, which would be 10 liters. Milliliter, what does milli mean? 1/1000, so 1 over 1,000 times 1. So think about 1, and you're going to move the decimal place to the left 3 times. So it's going to be 0.001, and that would be liters. And then centi means what? 1 over 100, so 1 over 100 times 1. So move the decimal place 2 times, so we get 0.01 grams. So a kilogram, what this means, like for number 1, a kilogram is the same thing as 1,000 grams. A deciliter is the same thing as 0.1 of a liter. Okay, like number 6, 1 centigram is the same thing as 0.01 grams. So they're just showing you how those relate. So on the next page, you guys should see this chart. This has some of those prefixes that we talked about, like milli, centi, deci, deca, hecto, and kilo. There are some other prefixes that are out there. You don't use them a whole lot because they're getting really, really large or really, really tiny. But some of them are used like in other careers out there. Like scientists are going to use, especially if you're looking at like a biology type person, or someone who's dealing with like looking at tiny things, tiny cells, looking at DNA, like that kind of stuff. They're going to be in really, really small units. So they're going to be using things like a nanogram or like a nanometer or something like that. Bigger things here, like a megagram, a gigagram, a gigaliter, those kind of things, those are going to be really large amounts, okay? Because it's like a million times, a billion times, a trillion times. That's a huge amount. So they're not used a lot when we're talking about like stuff that we're going to be measuring on a daily basis. You're probably not going to be measuring something that's known as like a teragram. You're probably not going to be measuring anything that's like a trillion times something. But they are out there. So those are some of those other prefixes. So let's go over, how do you know like which one to use? Because there's a lot of different types of measurement out there. Like for this first one, we're going to talk about meters. Meters and kilometers and centimeters and millimeters. So we have to understand like when is it appropriate to use those kind of measurements. Like for us, if I was going to measure my binder, I would probably do that like in inches. Okay, and most of us probably know that. Or if we're going to measure our height, we're going to do it in feet, because I want to know how tall I am in feet probably. But if someone threw something at you and said, would you do meters, kilometers, milliliters, or centimeters? Sometimes people don't know because we don't use those kind of things every day. So we're going to go over some examples here that kind of help explain how do you guys know when to use which one. So a meter is like the standard unit for measuring length. So examples of when you might use a meter to measure things would be if you're measuring the length or like the size of a room. So if you're measuring how long and how wide a room would be. If you're measuring land, so like if you're putting out a lot for sale, you would measure that in meters. You might use heights of buildings. And possibly even something like a mountain. So meters kind of have a big range of measuring things. Kilometer would be used for longer distances. So this would be for like the distance between cities. Or it could even be like the length of a country. So how wide a country is, how long a country is, how far between two countries. Now, I would argue that there's probably some mountains out there that you would also use like a kilometer to measure. Like Mount Everest, for example, they would probably use kilometers to measure that because it's a really, really big mountain. Centimeters are going to be objects that are less than a meter long. So we're getting a little bit smaller now. So centimeters would be used probably to measure like maybe the width of a tire. Clothing, textbooks, and then last is millimeter. And those are really small items. So these are things that would be too small for something to be measured in centimeters because it wouldn't even make up like a full centimeter possibly. So for example, that might be like the sizes of like a bolt or like even nails. Or it could be like something like you're measuring the length of an insect. So much smaller items. Okay, so that's for length. Now let's talk about weight or mass. So for weight or for mass, we have grams, kilograms, and milligrams. Those are the most commonly used ones. Grams would be like your standard unit, and so those aren't going to be something that's super heavy. It's going to be kind of like just normal everyday objects. So examples that I have would be like weighing paper clips. Like if you had a whole box of them, coins, like a bar of soap. Those would be measured in grams. Kilograms is 1,000 grams, so it's measuring bigger objects. So like our weight, like people, our weight would be measured in kilograms. Meat, like at a meat counter, or if you're talking like at a butcher shop or something like that. Grain, so like in farming, when they're doing harvest and they're measuring how many, how much they have like in corn or beans or whatever, that would be in kilograms. And something like cars. A car would be measured in kilograms. Milligrams would be tiny amounts. So you see that a lot used like in measurements when you're talking about vitamins, medications. So like if you've ever looked at a bottle of like ibuprofen or Tylenol or something, it's all measured in milligrams, like 500 milligrams. So that would be an example of how much that weighs or how much that is worth for your body to be taking in. And then lastly, we have capacity or volume. And two of the main ones that we have here would be liters or milliliters. So liter again is your standard unit. So that would be used to measure something like pop, like if you guys go to the store and you buy like a 2 liter of pop, or even like gasoline. So similar to like what a gallon would be for us in the US system would be like a liter. Milliliters would be really small again. So again, it could be used for like medication if you've got like a liquid medication. Like a lot of children's medication is done liquid because they don't understand how to swallow like a capsule of anything. So they do a lot of liquids for that. Or even like perfumes. If you're flying on an airplane, they have certain restrictions on how much, like if you've got travel size of like shampoos or body washes or whatever, it can only weigh so much or it can only have so much. And if it's over that, they throw it away. So it happens, especially like in airports like that. They're very picky about how much something weighs if it's in your carry-on bag. So that would be examples of when you want to use those things. So we're going to do a little bit of practice with choosing the appropriate measure. Okay, so we've got, let's see, 4 of them here. I'm going to give you guys a minute. I want you just to kind of look through them and you decide which one you think would be the appropriate measure, and then we'll come through and talk about which one it should be. Okay, for number 1, if we're talking about the distance from Jackson, Mississippi to New Orleans, Louisiana, they're giving you meters, kilometers, centimeters, and millimeters. Which one do you guys think is the most appropriate measurement? A, B, C, or D? B. Okay, kilometers we said is used to measure distance between cities. So kilometers would be how you measure something from Jackson to New Orleans. Number 2, the weight of an adult woman. Grams, milligrams, kilograms, or decagrams. What do you guys think would be appropriate? C. Okay, kilograms. We talked about that being appropriate for like weighing people. Number 3, bottle of eye drops. What do you guys think? D, milliliters. It would be a small amount. Bottle of eye drops are usually about this big, so you're not going to have anything a lot larger than a milligram there. And how about the weight of an aspirin? Good, A, milligrams. Those are going to be very, very lightweight, so you need something really small to measure that. All right, so when we come into converting from one metric unit to another, this is when I said a lot of times, because it's the metric unit and it's all base 10, it's a lot of moving the decimal places. You just have to know which way to go. So this kind of gives you like that standard chart with the standard unit in the middle, meter, gram, or liter, and then the prefixes above and below it. So the ones on top are the ones that would be bigger, the ones on the bottom would be smaller. And this kind of goes off of those prefixes that I was talking about at the very start of this section. So what you can do to help you guys do these kind of conversions is figure out, like if I was looking at this chart, mentally think to yourself, where would it be? Where would this measurement be on the chart? Like, am I starting with a kilogram and I'm trying to get to a centigram? Or am I starting at a meter and I'm trying to get to like a millimeter? Which way am I trying to go? Move the decimal either to the right or to the left, depending on which way you're going. So this way we're going from a metric unit to a smaller metric unit. So if you're going smaller, you're going to move it to the right. If you're going from a smaller unit to a bigger unit, you're going to move it to the left. And that comes down a little bit later. So let's take a look at how this works. If number 1, I have 43 DKM. DKM stands for deca. Okay, so decameters here. So we have 43 decameters. and I'm trying to go to centimeters. So I'm going to come up here for a second so you guys can see this chart. Right now, I'm right here. I'm at decagrams. I'm trying to get to centimeters. So I'm going to go down 1, 2, 3 to get there. That means I need to move my decimal to the right 3 times and attach zeros. So my decimal right here is after the 3. So I have to go to the right 1, 2, 3 and attach zeros to it. So my answer is going to be 43,000 centimeters. Okay, let's look at what number 2 says. 2 says that we have 2.5 dg. dg would just be deci, so decigrams. So coming back up here, decigrams would be 1 underneath the standard, so this is where I'm starting. Where I start is where I'm at, and I'm trying to go to milligrams. So I got to go down 1, 2. So I need to add, I got to move the decimal 2 places to the right. So I've got 2.5. I move it 1, 2 to the right. How many zeros do I need to attach for this one? Just 1. So it should be 250 milligrams. Now, if I'm going from a unit to a larger unit, I go the other direction. So instead of moving it to the right, I got to move it to the left. Okay? But you can do the same thing. You can go back up to that chart, figure out, like, where am I starting? Where am I going? This time we're going to be going to a larger unit, and that's how many times, however many movements you have to take, that's how many times you move that decimal place, this time to the left. So for this first one, I've got 3,495 liters. So where am I starting in my chart if I'm starting with liters? Good, standard unit is where I'm starting. And it says I want to go to KL. What do you think that stands for? Kiloliters. Okay, so I got to go 1, 2, 3 up. So I have to move my decimal 3 places to the left. Where does the decimal start for this number? Not after the 3. After the 5. That's where it starts. And then if I move it to the left 3, 1, 2, 3, then it's in between the 3 and the 4. So 3.495. So for the last one on this page, number 2, I have 2.78 cm. What's cm stand for? Centimeters. So let's come back up here. I'm starting at centimeters. I'm trying to go to DKM. What does that stand for, you think? DK would be for deca. So I'm trying to go to decameters. So I got to go 1, 2, 3 to the left. So coming down here, 2.78. 1, 2, 3. How many zeros do I have to add in front of my 2? Got 2 of them. So I have 0.00278. Okay, the last thing we're going to talk about is making calculations with metric measures. So we're going to talk first about like adding and subtracting. So if they're like each other, so if they're both in centimeters or they're both in milligrams or they're both in kiloliters or whatever it might be, you can go ahead and add and subtract them, keep that same unit of measure and attach it to the end. So if I'm taking centimeters minus centimeters, I just go ahead and subtract the numbers and I leave it as centimeters. Now if they're not like, so if they're different from each other, I have to change them like we did with the US customary. We have to change them so that they're in the same unit first. So if you've got like liters and milliliters, you got to change probably liters to milliliters and then add or subtract them. So for this first one, I'm going to do 9 milliliters and then I have 2 centiliters. I'm going to change my centiliters to milliliters. So if you go back and you think about your chart, let's go back there for just a second. I'm at 2 centiliters. So I'm right here, and I'm trying to get to just liters. So I'm going that way with it. I'm going to the left. Well, I think I might be moving in the wrong direction. Let me think here for a second. 20 centiliters to milliliters. I might want to take milliliters to centiliters instead, because otherwise it's going to be a tiny number. So what I might want to do is think about if I'm at 9 milliliters, right here. I don't think it really matters. We could do either one. I'm just trying to think what's going to be easier for you guys. Oh, I went the wrong way. That's why. Okay, so I'm starting at centiliters. I'm trying to go to milliliters, not meters. So I got to move it 1 to the right. That's why I was confused. So we have to take 2 decimals here. We have to move it 1 to the right, so we have to add a 0. So 2 CL is the same thing as 20 milliliters. So now I have 9 milliliters and 20 milliliters. So I'm going to add those two together now. So 9 plus 20, which would give me 29 milliliters. Okay, number 2, we want to go 14 kilometers minus 34 hectometers. So let's go back up to our chart for a second. So if I've got 34 hectometers, let's change that to kilometers. So am I going to move my decimal if I'm going up 1? Am I going to move it to the left or to the right? Left. So we're going to take 34, the decimal is right here after the 4. I'm going to move it 1 to the left. So that would be 3.4 kilometers. And so then to finish this off, we're going to take 14 minus 3.4, which would leave me with 10.6 kilometers. Now, if you had wanted to, you could take 14 kilometers. You could convert that to hectometers, so you would move that to the right one, so it would be 140, and then you would minus 34. So 140 minus 34 is going to be 106, and that would be hectometers, which is the same thing as 10.6 kilometers. So it doesn't matter which one you change to. Just know that your unit has to be, they have to be the same first before you try to do anything with them. Now, multiplying and dividing, just like we did yesterday, if you're multiplying or you're just dividing and it goes cleanly, just go ahead and multiply, especially like dividing is where it gets kind of messy. If it can go in nicely, go ahead and just divide. If you're dividing a metric measure by another like metric measure, if they're not the same first, you got to change one of them so that they have the common measurements again, and then go ahead and divide. If you get like a remainder or something, you'll have to write it the same way that we wrote it yesterday, or when we were talking about those U.S. customary measurements. So we're going to do just a couple of problems here, and then we'll be done. So 4 micrometers weighing 752 grams will each fit into a shipping carton. If the shipping carton and filler weigh 217 grams, what is the total weight of the shipment? So I'm trying to figure out total weight here, which if I think about this as like an equation, it's going to be my shipping carton, so however much the carton weighs, and then I have to add that to the amount that the filler and the 4 they're talking about micrometers are. So I'm taking like 4 times the filler. So what I'm going to do is, it says that the shipping carton and the filler weigh 217 grams. So 217 for that. And then each of those micrometers weighs 752 grams. So I have to take 4 times 752. So I'm going to multiply that first. I'm going to take 4 times 752, which is going to be 3,008. And these are both in grams, so I should be able to just go ahead and add those together. And that's going to give me 3,225 grams. Or we could rewrite that as 3.225 kilograms. Either one would be acceptable. Number 2 says that a 5-meter long board is to be cut into 4 equal parts. How long is each part? So you guys would be taking the 5 meters, you would divide it by 4. What's 4 or 5 divided by 4? It's going to be a decimal. .25 meters. Each one gets 1.25. Okay, last one. How many 25-gram packages of seed can be made from 2 kilograms of seed? So we're trying to take 2 kilograms and divide that by 25 grams. We got to get these to be in the same measurement first. How can I take kilograms and make it into grams? Move the decimal point. So think about it, kilograms is 1,000 times as that standard unit. The standard unit is grams. So we move the decimal to the right. So this would become 2,000 grams. And we're dividing it by 25 grams. So can you guys take 2,000 and divide by 25? What? 80. So 80 packages can be made.